Hello my friends, welcome to Inside Autotransformer channel. This is Uncle Misha. And today we have this beast. So this is Autotransformer made by RTC, I guess, company, made in China. So I got this for fairly cheap, but I hadn't chance to use it for a while. I was sitting in the garage for a long time. And when I actually needed to use it, I noticed it has this problem. So this is completely busted. So I'm not sure I busted it or I bought it busted. Didn't check, didn't pay attention. But here we are. So today we're gonna take a look how to repair this monster of an Autotransformer. Right. And also we will talk how Autotransformer work in general. So let's get to it. Alright, so before we actually start digging in, let's talk a little bit about theory, like what is Autotransformer first. So Autotransformer is a form of transformer and it works only on AC or alternating current. So it needs specific frequency to operate because it has the core. It is super heavy. It has the iron or other type of material core which actually transfer the magnetic energy. So it definitely works only on AC, like any regular transformer. So let's try to draw a diagram how Autotransformer works. Alright, so let's talk about how Autotransformer works. So schematic of Autotransformer would be something like this. So this is our winding, as I mentioned. Let's make it big. A little bit crooked, but that's okay. Here's our iron core. So it is connected to our primary side. Like every transformer, it's gonna have primary and secondary side. So this is gonna be our mains power here. It could be 110, 100, 220 volts, 240 volts, whatever your transformer is designed for. And then you notice it may have more turns than the primary because some of the transformer can regulate voltage within the range of up to 40% to 15%. Like this particular gentleman actually says it can do output 0, let's talking about this guy, 0 to 130 volt, while input is 110 volt. Input, output. Okay, so in this particular case it's actually 0%. How do you achieve higher voltage? You are tapping the transformer not here, where is the 110 volts, for example, but here. And because you have more turns, voltage here gonna be 130 volts. So for example, over here, secondary gonna be like this. This is our secondary. And because, for example, because we know that this particular Autotransformer has sliding contact, it's going to be like this. So if you're going to tap here, it's essentially going to be 0 because the potential here and here are going to be equivalent. And then when you move the big knob on top, you're going to slide this slider all the way across the transformer all the way to here, when the voltage is going to be 130 volts. This is how it works. So this is actually copper wire wound around big steel, probably magnetic core. And because this is transformer, it's still able to transfer this energy across the magnetic core, even all the way here. All right, so this is the basic, and this is, let me write it down, our secondary. Secondary. So this is, in our case here in North America, 110. And here is 0 to 130 volt. So why do we need such a device? In one of my videos, I was showing the Japanese unit, and in Japan, they use 100 volts. So I need 100 volts. So this particular device will be very handy to achieve that. So I'm not really sure what's gonna happen with Japanese unit connected to our mains, where it's a little bit higher voltage, but still, it may wreak the havoc in a device. So in order to eliminate that, you use Autotransformer connected to your mains, pick your voltage here. Let's say it'd be like your slider gonna be somewhere in this area, a little bit less than 110. Some of the Autotransformers, as mine, they have a little voltage indicator. It's gonna show the voltage on the output. So you just select it, and now you can safely connect your device where the voltage is actually lower. So the Autotransformers are very handy for converting voltages between devices which are from different countries. Well, this particular not gonna help me with 240 volts. If I, for example, have 110 and on this side I need 220 or 240, it's not gonna help me. So I need much more windings in this transformer, like way more, like twice more, to actually do that. And this transformer is not gonna help me. But in order to regulate in between 0 to 130 volts, specifically for Japan-made units, this is gonna work for sure. And this Autotransformer is a beast. So, okay, now we understand how Autotransformer operates. Just let's actually dig in. Yeah, certainly this thing is big and heavy. And because it's just only one big massive transformer, only with few things, like it has a switch here, it has a voltage indicator or like a dial, it has output. I'm not sure why they included European output here, because it can't do 100, it can do 240, 220, and obviously a power cord. This is the bottom. It's a bit rusty, I think. No, it's not rusty. That's that old school material. Oh wow, insulating material. That's very good. So this, I thought this is metal. It's amazing. All right, this is interesting. So and obviously here we see this like big ass scratched a bit. This is kind of stupid. Yeah, it's a bit scratched. I hope no one gonna poke around here while this thing is working. Yeah, I may put some Kapton tape here just to make sure there is no electrical contact. I'm gonna just double check that. This is stupid. Need to be kind of covered. I don't know the current rating of this device. Probably we can take a look at the fuse. I don't know if it's original fuse or not, but yikes. I don't know if you see that, but fuses certainly seen better days. It's 20 amp fuse. Okay. I don't know, looks like the 20 amp fuse is busted. What the hell they were doing with this thing? Yeah, let me check. Maybe it's not busted. I'm gonna do multimeter, gonna switch it to... It's not busted. It's not busted. It just... I don't know what the hell happened to it. Unless it's... I don't know. It's bizarre. It's all not rusty. It's all clean. Okay, so I have better fuses. Okay, so this is... Let me check something else here. So I was not sure if this thing is safe. So let me check grounding. So chassis is not grounded. This is just this center grounded here. I'm checking that there is no short. So how do we access this thing? Okay, probably definitely need to remove this top. There's a screw right in here. Let's just take a flat head screwdriver and keep poking around. Okay, here we are. So remove this top thingy and big knob. Let me unscrew this guy. I'm not sure if it's necessary. No, it's not necessary. It's not necessary because this just holding this dial. So this is big swiping thing. Wow, that's really amazing. Some beefy wires here. Okay. So now in order to reach further down, probably need to unscrew a whole bunch of screws on the perimeter. Yes. Yeah, a whole bunch of screws. Oh wow, everything's falling down. So I need to unscrew a bunch of screws right here from this insulation bottom. I'll do it off camera. Alright, so after removing a whole bunch of super long screws, as you see here, and bunch of screws on the perimeter, it was like actually 5 of them, one here, over here, and 2 from this side right behind this box. Now we can remove this. Hey guys, I just realized something after I took all this apart, that resistance, measuring resistance here is actually wrong. Why? Look at this. So this is input here. So this is wire coming from the outlet, not outlet, yeah, from the input outlet, and it's soldered straight to the core, to this core wire. So this is pretty thick copper wire, about 1 millimeter, maybe even bigger than 1 millimeter thick, right? Yeah, actually it is bigger. It's like about 1.5, 2 millimeter thick. So resistance in there will be pretty small. Now look at this. I'm measuring resistance. Yeah, I got it. 6.3 ohms, obviously, because it's not like a miles of turns, right? So the whole length of this thing, all the way up to here, up to the other end of other side of the mains, like, you know, is actually measuring only 6 ohms. Look at this. What the hell? Okay, and let's measure right here on top of the, pretty much here. Yeah, so get it. That's the resistance. So yeah, I mean, forget about the resistance. So what you have to measure is a voltage under AC current. So that's the only you can actually judge by that. So I want to show you also something super interesting in the construction of this thing. So this rotating top is the brush, essentially. So I'm gonna show you with my phone because it's really hard to take video. So here is the brush. It's actually rides on that surface of the coil. So all of these turns, they have grind out top, and now this brush essentially rides on it. And look at this, it's like actually it moves because there is a spring. The whole thing moves as brush deteriorates, right? This is amazing. So essentially this eventually gonna worn out. Not sure how many moves this thing requires, but there is a brush. I'm curious if I can find this brush if I need to. Anyways, this is amazing. So obviously it's gonna leave some kind of carbon deposit right here. So this, I assume this has to be cleaned up. Look at this, it looks pretty kind of dirty. Yeah, look at the massive iron core here. It's really hard to tell, but this core is like freaking massive. It's probably yay big, like the core is yay big. So this is like, this thing weighs probably 10 kilos. All right, this is another spring. Sorry, not spring. Yes, has to be. Oh, it just relies on that one spring. So this is the mechanism. Yeah, so you can change the brush. So this is pigtail for the brush. It's pretty cool. So what now I have to do is clean all this top. Brush seems to be in good condition. I tested the continuity between the brush, which actually gonna add some resistance, obviously. Let's say 14 ohms. Yeah, it adds some resistance. Okay, so definitely gonna clean it up lightly, brush it up, and we will continue. But actually stop, no, we're not gonna continue. We need to fix the wire here as well. So this has to come out. Do I have to? I'm checking where the wire go. Yeah. How to deal with this panel separately. I'm thinking it would be so amazing to install EX standard plugin here. It would be so much more convenient to have this. Maybe that's what I'm gonna do. I'm gonna unsolder all this, remove this crappy cable, and install EX standard plug. Yeah, because it just it's only 10 amp, but like, I mean, I'm gonna pass more than that. You're gonna also put 10 amp fuse or something, or 15 amp, depends on what kind of cable I get. So because this is so annoying, I think that's gonna be my plan. So yeah, I'm gonna essentially remove all this. I'm gonna drill or I don't know, use some kind of metal saw the little rectangle specifically for the EAC standard plug and just use it here. A kind of annoying job, obviously, but at least I won't be won't have to care about these, like, how do you call it, the strain reliefs, which are completely gonna destroy over time. This cable even compromised, because it looks like it's like, yeah, I don't trust this cable anymore. It's better to get some good EAC and then EAC cable and EAC standard plug here. So I have to think, how do I cut it out, but for now this is gonna be my project going forward. Well, it turned out to be I don't have in stock any of the just standard EAC power plugs. So what we're gonna do today, we're gonna just remove all this, cut some wires here, and prepare and order some and wait for the shipping. But I will prepare this stuff to be ready when it is arrived. Obviously I have to wait for its arrive to make sure the dimensions are correct. But for now, I'm gonna just cut this out. Like all these wires, gonna completely cut them out, like here. Okay, push them through somehow using the pliers. Or maybe one by one. Okay. So this all gonna go to the newly installed installed power plug, and this guy, this like strain relief, gonna be freaking cut out of here, which actually didn't do a good job of strain relieving duties. Okay, here we are. This is the shitty strain relief. Okay. So now I have this nice hole here, which I have to, when I get the EAC standard power plug, like similar to this one, I'm gonna measure it and actually use the Dremel and cut out the nice little hole and insert it, and then solder those, or maybe crimp solder, not solder, just crimp them. Maybe solder. Maybe solder gonna be better for the current capability, current carrying capability. I don't remember where this came from, honestly. I don't remember. No, that's pretty cool. If it was like down there, it was stupid, because yeah, because this case is not grounded anyways. I don't get it. And this is not conductive as well. I think it was done just for stupidity, because this is like, there was no, the paint is not removed, right? So obviously if paint is not removed in the area where this thing screws in, it's like there is no point of doing that. It's retarded. But anyways. Oh, unless it was contacting the screw itself, maybe. So now, while I'm waiting for the power plugs, I'm gonna do some other project. Let's just put it to the side. Ooh, finally! Jesus Christ, now I have to like clean all this up. It's a bit good I done it in the laundry thing, but now this thing fits. Maybe a little bit crooked, but I don't care. Now we're gonna hammer this thing back in and I'm gonna solder everything together. Okay, so now we have our new bench and we can continue this project further. So this is, as you saw in the previous short videos, how I was cutting this hole. So I made the hole to the size, and this guy now is gonna fit right in here. A little bit snug, but that's good. Okay, so what we have to do, we have to unscrew all this and solder the leads to the outlet. Okay, maybe I'll do it on angle or something. Okay, now I have to unscrew all that. I'm gonna do it off camera and then I'll continue. Okay, so let's figure out our wiring. So we have here earth, neutral, and the ground and live. So judging by this fact that this wire goes through the switch, I'll double check obviously that, then it goes through the fuse and goes to transformer. I assume this is live, this is neutral, and these two, this and this are earth. So this was screwed somewhere, I don't know where. Need to figure this out. Probably somewhere here. Okay, just to make sure that the case is grounded. Yeah. Okay, so let me. It's good to have this thing. Very handy. And then need that crap here. And this one. Whoops! What just happened? No! Ho ho ho! Look at this Chinesium crapola. Sucks. It's actually broke all the way. Okay, so we are continuing. So obviously this thing is broken and I don't have any other stripper, so I'll try to do something to this extent. I'm not sure that's gonna work though. I'm not as freaking strong here. Ah, it did work. Okay, that's better. It did work after all. So now I have to solder. I'm curious. It's better to use no, better to solder probably. Yeah, I'll probably solder them. Let's turn the soldering iron on. And get some soldering supplies. One thing to do is to double check. So one last thing to do is to double check the wiring just to make sure I'm not wrong. So Okay. Okay, so this is ground. You can solder this first thing. Well, looks like I need larger heat shrinks. And actually put them a little bit further down there. Because this is already solidified. It's not solidified, kind of heat shrunk. Okay, that's gonna be good. Okay. Ground has been soldered. Next, gonna be neutral. Let's do live next. Oh, what I'm doing. So now when we have all wires tinned and we put pretty thick, I decided to put bigger heat shrink, we need to insert this in the place where it's supposed to be. So we're gonna turn this around. Maybe we would need to apply some force here. No. Ta-da! It's pretty good. Pretty good. I hope it's not gonna pull out that easily. So now we would have to solder it, and soldering in this position will be kind of hard. Wow, maybe maybe try to access it from different angle. It will be easier. Maybe not. You can use fluke as a prop. A little bit easier, at least for the ground. No. Oh, you don't see that. Oh man. Alright, I'll try to sit as well. Let's do some soldering here. So this is clearly ground. Okay. Okay, ground is soldered. Next one. It's awkward. It's pretty awkward, but at least. So this one is neutral. Okay. Neutral is this guy. Alright, this one is done. And then, what is live? Looks like I need to do better thinning job here. The bottom is not thin at all. Alright, so let's just put this back. Okay, trolley number 2. Let's do it a little bit better this time. Okay, that's much better. Now we have to put those heat shrink tubes on. Where's the... No, fuck, no. Looks like neutral heat shrink falling out, and I didn't even notice it. Did it? Yeah, it did fall out. My god, that's annoying. What is it to desolder? Okay, just clean this up, nice and smooth. Get the heat shrink, put it back. Clean the eyelet here. Just try to solder it again. Should be good. Okay, now I need to heat shrink all this stuff. I'll bring this thing back to the shrinking station because I don't have it close by. Okay, so now it's all nicely heat shrunk. I don't know if you really see, it's really hard to show you, but for me it's looking good. Alright, so what I have to do next? So next I have to hope it's gonna rip off any wires because this is insane. I think it's gonna be like this. So now I'm not gonna be like twisting and turning it, just gonna keep it like this. Just turn it back towards me like that. So now I have to remove this top again. So I've done it once, let's do it one more time. So there is a... Why do I have to remove the top? I'd like to actually clean it up. Okay, remove this. A whole bunch of screws at the perimeter, but they are tiny screws, so they unscrew pretty quickly. What's cool about these screws, they are universal, so you can use either flathead or Phillips for them. So I like this a lot. Yeah, this is more appropriate. Just I don't want to move this thing too much around. That's it. Yes. No. There's one more here. What's going on? And this one, for whatever reason, is only Phillips. Sorry, only flathead, unless it has some kind of gunk in it, and it just... Yeah. So what I would like to do now, I'd like to clean this surface. So first I'm gonna use, oh yeah, look at this. I'm gonna do it somewhere else. Yeah. Unfortunately I have to move this thing again. Yeah, it's gonna be super dirty, so I'm gonna do it when not on my desk. I'll be back. Okay, so I cleaned this thing up as much as I could, so this surface is nice and clean. Also, I used the bronze brush to kind of brush these these contacts, let's say, and clean up. Then I use alcohol. So let's just assemble it back together. I think we're done here. At least we're done cleaning, and then we have to put it all together, which is another procedure. A little bit kind of annoying sometimes, but it's a procedure you have to do. Annoying because it's like it's heavy and I'm afraid to rip the wires off. That's why I try to move this thing as less as possible. And I think it's dusty as well. I tried to brush it off and like it was a lot of dust inside. Hope I didn't breathe in any carbon deposits and stuff. Right here. Here. And two most annoying, like the ones are which are inside. Yeah, this I don't know who kind of genius came up with this. Because they really not accessible, these guys, which are behind this thing. Okay. Okay, I've done the most annoying part off camera because it will be long and dreaded. So now I'm screwing in these guys, which is another, for some reason, annoying job because for some reason this screw is almost stripped. Okay, this is good. Hope this is... Yeah, right, good luck with that. You now have to aim because some genius... Oh my god. Didn't think. So now I have to like turn it upside down and aim the stupid screw all the way across the thing into the chassis. I don't know what the hell they were thinking. Well, it's doable, but like annoying. Ah. Not like it's stripped. Amazing. I don't think I stripped it, but oh, this thing's heavy. So the last one, the screw is right here. I didn't tighten all these jaws because okay, now I can tighten all this because I wanted to make sure the case gonna go properly. So this will on this side properly, oh, and on this side it's not tightened. Now, oh, I'm so impatient now. Where is the arrow? Okay, here. Okay. Let's see this long one. Cool. Okay, well, here we are. So for some reason this thing has European output, like, kill me, I don't understand why. Ah, it's actually not European, it's universal. Let me check something. So I have this power cord, let me see. Oh yeah, it's universal. But still, like, it's why would it be European here? I have no idea. Is it European? Maybe. So right. Okay, this needs to be tightened better. Looks like this got stripped actually, which is not cool, but what can I do? Okay, it's a moment of truth. Hope it's not gonna blow up on me. Okay, we go 0. Now we're gonna power this thing up. Alright, so moment of truth. So it's powered already, you see the plug. Okay, it's because it's 0 volt. Let's see. Oh, it's going up. Yeah, it's wibbly wobbly, I don't like that. Is it can really go 150? Wow. Okay. VAC. Let me see VAC. Yeah, it's really kinda not cool, but it's not gonna short anything anywhere. Anyway, it's gonna hold them. Okay, let's see. It says 6 volt. Oh, it's going up. 12. Okay. 97. 110. Okay, it's pretty spot on. So for some appliances you need 100 volt, for example. So that's going to be 100 volt for the Japanese devices. So let me see 100 volt, how they look like. Yep, a little bit less. Yeah, I don't know what's happening here. That's just bad contact. Okay, need to hold them better. Okay, and let's go up. Huh. Not like I needed 150 volts, but it clearly can go 150. I think they said 130, aren't they? Okay, let's put back to 0. So guys, I think this is success. So we have now Autotransformer which works, and we change the plug from kind of piece of wire to standard North American plug, which is pretty cool. So I think that's gonna be it for now. And now if I need like for example, test some old equipment which requires slow bringing a voltage up to operational voltage. So for example, from some special tube devices that don't like to be like, you know, hammered right away. So kind of you slowly bring the voltage up like this, okay? Oh, just another thing I would like to test. If this 100 actually corresponds to 100 volts on a voltmeter. No, it doesn't. It's actually higher. So 100 is here, pretty much at 90. Very interesting. Oh, I think I know what's going on actually. So my input voltage right now, probably 120 volts. Yeah, this is why I have 150 instead of 130. And 100 volt is at 90. Yep. Anyways. Oh, there's even indication here at the bottom. So yeah, they say input 110, output 130 maximum, but looks like we have 120 at the input here. I'm not sure how, but yep. So 120. That's why we have higher voltage at the output. So that explains it. So guys, I think this is success. A video is success. I like that we restored this guy. It probably was operational in the first place. We just cleaned it up. We just added the proper plug, and we can now use it, store it without plug, because it's super annoying, you know, to have this long wire actually sticking out right here. And now it's much more compact, and I can use any wire I want, any length and any place, and I have to drag it with the wire. So yeah, this is good. So this device is actually pretty useful. It takes a lot of space, unfortunately, but I'll try to find the accommodated. And I think I'm gonna wrap up. So now we know a few things. First, how this thing operates. Second, that we can actually easily replace this plug, and it's much more versatile now. So thank you guys for watching. Hope you find this video useful, enjoyable, and please stay tuned for more videos. Stay safe and ciao.